Welcome to the Deep Dive. Today we're digging into, well, a whole stack of sources.
Yeah, quite a mix this time.
Definitely. We've got stuff from communities like Reddit's Arving Science, Our Today Learned, alongside, space.com, Gizmodo, NPR.
A good range.
Our mission, really, is to pull out the key takeaways, explore some, frankly, mind-bending facts about Earth and space.
And maybe understand why these things matter.
Exactly. Why even small changes can be significant. So, yeah, get ready for some aha moments.
Sounds good.
And we're kicking off with something pretty surprising right here at home. Our planet is actually speeding up.
Making our days shorter.
Yeah, some of the shortest days in recent history, apparently. Okay, let's get into that. And the basic idea is Earth's rotation is accelerating. Just slightly, but measurably.
Tiny amounts, yes.
We saw this specific claim, I think it was on Reddit, citing space.com, that Earth will spin faster on July 22 to create second shortest day in history.
Right, that specific prediction.
And it's not just like a one-off thing. We saw an astrophysicist warning about basically goodbye to 24-hour days.
Well, a potential goodbye.
Right, potential. Noting Earth's rotation would be, what, 1.66 milliseconds shorter?
Yeah, sometime in the next 2 months was the quote, I believe.
Which, sounds tiny. One Reddit user joked, "Great, that will throw off my sleep."
Yeah, understandably.
So the real question is, how does this actually affect us? I mean, are we going to feel this speed up?
Well, no, not directly. 1.66 milliseconds is incredibly small. You won't notice it at all in your daily life.
Okay, so no sleep disruption then?
Definitely not from that. But what's really amazing is that we can measure it.
Oh, right. The precision.
Exactly. Atomic clocks track these things. And these tiny shifts, they tell us something important.
Like what?
It's like listening to Earth's heartbeat. It fluctuates. Heartbeat.
How so?
Well, it's influenced by just massive forces. Think deep seismic activity, melting ice caps, shifting weight around, ocean currents, even atmospheric pressure. It's all connected.
So the planet isn't static?
Not at all. It's a living, breathing system, you could say. Its pulse changes. And understanding these subtle shifts helps scientists build, a better, more dynamic model of our world.
That's a really cool way to think about it. Earth's heartbeat. So it's less about us feeling it day to day.
And more about what it reveals about the planet itself.
Exactly.
Bluntly.
Okay. And speaking of things challenging our assumptions, let's look outwards. Near-Earth objects.
Yes, asteroids. Always a popular topic.
Definitely keeps people interested and sometimes surprised. Remember that asteroid back in 2032?
Vaguely, yes. The menacing one.
That's the one. NPR said astronomers were tracking it, and Space.com even mentioned a 1 in 83 chance of hitting Earth.
Yeah, those initial odds sound pretty stark, don't they? But that initial alert, it really shows how space observation works,
How do you mean?
Well, at first you have limited data. The path can look worrying.
Right.
But then more telescopes look, more data comes in, and the picture gets clearer. Our understanding evolves.
So the threat level changes.
Exactly. And what's interesting from the sources is, while Earth was eventually cleared for that 2032 asteroid, Gizmodo pointed out our moon might not be.
Oh, wow. The moon.
Yeah, and it wasn't alone. Another asteroid mentioned had a 3.8% chance of hitting the moon.
From an unusual spot.
That's what Gizmodo reported. It just shows the complexity, the celestial mechanics involved. Things are always moving out there.
And we saw a similar pattern, didn't we, with asteroid 2024 YR4?
Yes, that's another good example.
There was that initial headline, kind of alarming. Increases again. Chances is now at 3.1%.
Gets your attention, for sure.
But then later, thankfully, AP News had the update. Asteroid 2024 YR4 is no longer a threat to Earth, scientists say.
Phew.
So it makes you wonder about those initial scary headlines. Are they necessary to get people observing, or is there a better way?
That's a really good point about communication, but the initial warnings, based on preliminary data, they are crucial.
Why is that?
Because they prioritize an object. They say, okay, everyone, let's focus on this one. Get more eyes, more telescopes tracking it long term.
Ah, I see. So it kicks things into gear.
Precisely. Then, as more data flows in, the orbital calculations get super precise.
And they can confirm if it's a real threat
or just a close shave, a cosmic near miss. This whole process, this rigorous checking and rechecking, it's vital.
Okay.
And it helps us tell the difference between, genuine concern and just something flying by, maybe putting on a show.
And speaking of shows, but like regular ones? Our sources mention this. An asteroid will dramatically burn up in Earth's atmosphere today.
Ah, meteors, fireballs.
Right. It's a good reminder that while we track the big political threats, this kind of thing happens constantly. It really does make you rethink things you thought were settled. And speaking of rethinking, let's talk about the moon.
Our closest neighbor.
Yeah, you think you know it, right? But we found some fascinating stuff, like this Today I Learned fact. The moon has days and nights.
Well, yeah, it's technically true.
But here's the kicker, right? Each day is about 2 weeks long, followed by a night that's about 2 weeks long.
That's the part that blows people's minds, that slow rotation. And it's incredible to think about the effect of that. That super slow spin, plus no atmosphere.
What does that do?
It leads to the most extreme temperature swings imaginable.
How extreme?
During that 2-week day, it can hit 260 degrees Fahrenheit.
Whoa, boiling point, and then some.
Exactly. But then, during the 2-week night, it plummets down to maybe negative or 280 degrees Fahrenheit.
Minus 280, that's unbelievable.
The swing is enormous, over 500 degrees Fahrenheit difference.
Man, makes you appreciate Earth's atmosphere.
Absolutely. It's our thermostat, our shield. Future moon bases will need some serious insulation.
Seriously. And we found some more human observations, too. People enjoying the day moon, seeing it during the daytime.
Yeah, that's always nice.
And discussions about the southern hemisphere moon, how it looks upside down compared to the northern view.
A matter of perspective, yeah.
But this one was really intriguing. A personal observation from a stargazer. Saw the moon turn deep red this morning, March 9th, 2025. At 5:10 a.m., no one else seems to have caught it.
A deep red moon. That's unusual outside of an eclipse.
Right. They asked if anyone else saw it. Makes you wonder what subtle things are happening up there that maybe only one person notices. And that kind of unexpected thing leads us right into some other, mind-bending cosmic stuff from the sources.
Okay.
Let's start back here on Earth again, actually. This quote from Yahoo. Earth has tilted 31.5 inches. That shouldn't happen.
31 inches. That's significant on a planetary scale.
Yeah, shouldn't happen.
Well, the sources don't fully explain the why for this specific tilt, which leaves it a bit mysterious.
Right.
But what's unsettling for scientists isn't just the tilt itself, but how such a big shift could happen without some obvious huge event, like a massive impact.
So what could it mean?
It makes them rethink models of Earth's internal dynamics. Maybe there are forces deep inside, processes we haven't fully grasped yet.
A challenge to our understanding of our own planet.
Even as we look out at the stars, yeah.
And it definitely brings up other big questions. We saw discussions like, is it true, easier to leave the solar system than hit the sun?
Ah, the orbital mechanics paradox. Sounds counterintuitive, doesn't it?
Totally. And someone else wondering about, like, an endless void, all black, between our solar system and the nearest star system.
The sheer scale of interstellar space.
Yeah, these questions really stretch your brain.
Yeah.
And then this last one, truly baffling, from space.com. 1,000 stars are fleeing home in a hurry, and scientists don't know why.
1,000 stars fleeing. Yeah, observations like that. The weird physics of escaping the sun versus falling into it, these stars seemingly running away. It just hammers home the vastness.
And the mystery.
And the mystery. For all our incredible science, there's just so much we don't know. The universe is full of puzzles.
Endless curiosity.
Exactly. It keeps pushing us.
And that really ties it all together, doesn't it?
Yeah.
This whole deep dive. It shows how dynamic everything is.
From our own planet speeding up slightly.
To asteroids keeping us on our toes. The moon's extremes.
And yeah, even stars doing unexpected things far away.
It just highlights that even in places we think we know well, like our own solar system, there are always new discoveries.
New understandings. Our knowledge is never static.
It's always evolving, always expanding.
Which leaves us with a final thought, maybe for you listening. Given all this constant change, these ongoing discoveries, what's the next big thing? What fundamental truth about the universe might we uncover next that completely shifts our perspective in ways we can't even predict right now?